some like a bit when we try to upload the videos on technical aspects of things that we did. For today, I would like to talk about our experience at PWN2OWN, what it takes to participate in this game. And I have prepared 2 exploits, which we used in PWN2OWN and which I would like to dive a little bit more on the technical aspect. So let's start with the PWN2OWN. So we started PWN2OWN back in 2019 in Tokyo, and we participated in total of 5 competitions. And back in like Tokyo 2019, that was the on-site competition, and that was the first time for us. We always wanted to take part in PWN2OWN, and so we are very happy to have this opportunity. And I can say that the experience that you gain from each of every single session is very valuable and helps you improve as a researcher. So back in 2019, there was only on-site competition taking place. So that means we had to travel to Tokyo to be part of the PWN2OWN. And I must say that it's really, really nice experience. Definitely in 2019, there were less teams playing. So it was a bit easier to not have a collision with other teams. But then in 2020, everything changed due to the coronavirus, and ZDI decided to open the competition for the online participants as well. And that changed the dynamics of the competition a little bit, because that means way more people are able to participate. So that means there's more competition. But it also means people will be targeting a lot of the same devices. So that I think that takes a bit of the downside effect. So you're going to have a lot of people trying to hack the same device over and over again. So all in all, like for me personally, I like the on-site competition much more, because you go there with your own laptop, your own exploit, you run it against the target. There's all the thrill, the energy and adrenaline rush. And then when it's online, you have to hand over your exploit remotely and just watch it like somebody is executing on your behalf. So a bit of the I didn't like that approach, but I can understand that not everybody can travel for the on-site competition. Actually, I just realized I maybe should also mention what the competition is about, so that the ZDI announces the target list a couple of months before the competition, and then you as a researcher, you have a time to find and exploit the vulnerabilities in the specific targets. The very important rules are that it has to be remote code execution, and then it has to be 0-day on the latest firmware available during just before the competition. So no end days, no old firmwares, 0 days. So that's the rule. And then when you prepare for the competition, you have to decide if you want to participate as an individual or as a team. So obviously, when you play individually, you have less chances of winning more categories, because there's only a short amount of time that you can spend researching the target. And as a teamwork, I think it's also like much more interesting to have like at least one person that you can work with and exchange ideas, because it's not only about the end goal of pointing the target, but it's the entire process that you can learn together and support each other. So for us, we were in completely different time zones, so we could split our work to work around the clock. So when one person was working, the other one's taking over later. So we could speed up the work like this. And obviously, the fact that we already knew each other helped a lot. So PWN2OWN kind of goes through the cycle. Like when it was created a very long time ago, you had a lot of like individuals or a small team participating. And in a long time, you could have like a very good exploit on mobile device that just one person could develop and exploit it. But then later, as it gained popularity, the companies started to play as well. So you had a lot of like big name companies that had like 5-6 researchers, a lot of teams from China, where it had even more researchers. And what that created is that the individual or small teams like us, two people that have very big problem, could not like really fight for the entire win in the competition because they were just too small. So the companies started to play against each other. They wanted to have like a credit and a fame and everything. So they started the small teams and individuals just started to drop off. And when the Chinese companies were not participating anymore, it kind of like flipped again. So there was an opportunity for smaller teams and individuals like us to participate. And now I see the cycle now after the online participation was allowed, that the companies are again jumping on the stage onto the game, and they're just putting a lot of like resources, effort, and researchers into the game. They want to like promote their business. So it's again like a situation that there are more companies than individuals playing at PWN2OWN. Again, I guess in the next cycle will be again like at some point that the companies will drop off, and then people will be able to like small teams and then individuals will be able to play again successfully. But PWN2OWN is not only competition, that you really create a lot of like relations with other researchers. There are so many smart researchers playing, and especially if you go on site, you have a chance to spend time with them. Everybody's super friendly, sharing their knowledge, approach, and everything. So I made so many friends through the competition. That's like super awesome. And last but not least, if you decide to play it, in our case, that's a lot of like grinding. We had full-time jobs, and that means we had to dedicate our spare time and weekends into playing the hacking, and that's a lot of commitment. So it probably every now and then you can find some quick wins, but usually it takes really a long time to find something really useful or something that will be very robust at the end of the day. So you have to prepare to put a lot of work. So I guess that's why now the larger teams have advantage, because they can split their targets between other people. So if you have like 8 people in a team, you could split 4x2 and then have like each person look at different target and then just go to the competition with 10 entries or something like that. But PWN2OWN is also the vendor game. So what happened, as I mentioned, the competition, just before the competitions, the DI is patching and updating firmware for all the targets. And what vendors like to do is that they will push the update just before the competition. So like they do it on purpose so that you as a researcher, you don't have enough time to find a backup or like a new vulnerability or fix your chain. But I see kind of this as it has a side effect, because it happened to us that the Western Digital, for instance, just a couple of days before the competition was put in a new generation of the operating system of one of the targets. Obviously, everything was changed, architecture was changed, so our exploit that we prepared was not working at all. And then by the rules, we cannot participate in the competition. So what means is that we, with complete 0 day, are we don't have a way to actually even to demonstrate it and to hand it over to the vendor. So the situation is that there are a lot of devices out there which are vulnerable, and the vendor doesn't have information about the vulnerabilities because they decided to outsmart researchers and just patch before the competition, right? So we handed over to them, but they still didn't respond. They didn't like to fix it. They said, "Oh, we don't care about that product." And obviously, with embedded devices, it is a bit more difficult that there are so many, like, users are not used to patching as often or as quick as mobile devices. So for months there are outdated devices out there. So that causes a problem, obviously. And yeah, like, the problem is that it happens every single time. I don't know how many times our exploits were killed just before the competition. It happened a couple of weeks ago as well with Blasty. So be ready for this. And then the vendors, they have different way of responding to the competition. So some vendors will be very happy and they will see the value that they have been like a target for Pwn2OWN. They see the value of like a very smart researchers looking at their product, and they will patch very fast. So we had we had one vendor that patched overnight. So within 24 hours, they released new firmware software to their customers. Some vendors will feel challenged and they will try to defend their image as much as possible because they feel like this is like a PR thing. So they don't want to have people talking that they hack their devices, and they feel like more like, offended. I don't know, just weird. So usually these are the people who are like pulling some strange tricks against the researchers. And then you have some vendors that they ignore it completely. They don't respond to disclosed vulnerabilities, just like, leave me alone there. What is important is the strategy. So every team, every participant will have different strategy. I can tell you what worked for us and what was the strategy. So we discovered that the attack surface enumeration is really, really important here. So before you even start jumping into reversing and looking at the, hunting for vulns, you should have a very good understanding of the target and what you can trigger, what things can happen, what is possible, and what kind of attack surface there is really. So to give you an example, for instance, but sometimes more targets are more difficult with the attack surface. So like we had Arlo camera, and the architecture was that it was not exposing any services locally, and it was communicating with the backend server. Everything was encrypted, everything was fine, and you, as a controller of your mobile phone device, you were also connecting to the backend server, and you were sending commands to the server, and then the camera was pulling those commands from the server. So that was the attack surface was relatively small because you couldn't have any services attack. You couldn't attack any service locally. So that's it. And then you have to pick your targets carefully because there will be a lot of targets to choose from, and there will be a lot of collisions, especially now with the online participation. So you have to try to figure out like what other people will be looking at, what are the low-hanging fruits, and probably don't go after them, or maybe go for them if they're like, if you already have something interesting and there is some time left. But try to find vulns which are less obvious, right? So there's a higher chance they will not be found by other people, also by the vendor, and they will survive under the competition. And then, so this is what we did. We focused just on a subset. We left some like LAN vulns for a time that we still have left before the competition. And then we went for some like a common services, like less obvious. And try to have backup, especially for high payout targets. Here is the list of the vulns that we have been finding. And if you look at those carefully, you can see there are like a lot of different types of vulnerabilities. So starting from like typical stack overflows and memory corruption, Then you have like a command injection, directory traversal, logical bugs, hard-coded stuff. So you can see that there are really, really a lot of things that you can find and use. But many times you have to chain them. So that means don't try to limit yourself only to one class of the bugs. You have to be open-minded and try to be creative of how you find them. So now we'll try to move on to one of the exploits that we used in Miami. So in Miami 2020, there was a completely brand new edition of PWN2OWN, which was focusing on industrial control systems. And what that meant is that there are a lot of targets running on Windows-based systems and using Java and .NET components. And we really like it because the impact of pawning SCADA systems is very high. So those systems are running in the factories, in energy grid, controlling critical infrastructure. So if you have code exec on them, then there's a potential for a lot of damage. So the example of this bug is, many people think that they're mostly memory corruption, but this is something completely different. There's a logical bugs that we used, and with a bit of like a conventional way of like looking for a vulnerability for PWN2OWN. So the target was Rockwell Factory Talk SCADA, and we were able to get the remote code execution as an unauthenticated attacker, and the system was running on Windows installation. We had to chain 5 separate vulnerabilities together, and that was unauthenticated project copy request, which I'll talk more in just in a second, the directory traversal, race condition, and 2 information leaks. And fun fact is that we discovered all of those as a black box testing. So we didn't even start reversing nothing. We were just like poking the system and then just like getting further and further. So that's why I'm saying like you don't always have to like just start reverse engineering everything, understand or the architecture. Sometimes you will find those kind of bugs as well. So the first vulnerability, unauthenticated project copy request. So the factory talk runs on Microsoft IS, and it exposes the REST endpoints, which are accessible by the remote client, remote person. And one of those endpoints is handled by the HMIS IP DLL. And then it just like deals with the request that you're sending. And then there was a start remote project copy API. And then if you just send the HTTP GET request like this, so like you specify the target, some like URL. Here is the start remote project copy that we have just mentioned. And then you specify the project name that must exist on the system. Some random string, and then the lhost. So that is the domain or IP address of the server that will be contacted. So you can see this. The name is already quite descriptive. So it's just like starting some like a remote project copy. Like awesome, like a very good start. So if we send this request to the target, to our SCADA system. And then if the project name exists, so it must exist on the target, then the target will issue an HTTP GET request to the lhost, to our controlled lhost like this. So lhost, backup HMI, and then the project name and some like other information. So that's very good. It's very good information. And then the lhost must respond with the HTTP OK, and then specify the file name in the body. So when the target receives this response, it will send the HTTP GET request to the L host again with the following URL. So now trying to fetch the file name. So on the diagram, it will look like this. So we send the start remote project copy to the SCADA, then it sends backup HMI. We respond with HTTP OK with the file name. The SCADA sends the GET request for that file name, and that file name is sent to SCADA system. So as an attacker in the or the L host in this case, we can respond with any content that we want, right, to that in that file. So we send the actual file of the file name. So the target, when this file is received by the target, it will write this data to this file path, perform some actions on this file, and then immediately delete the file, that file from the file system. And that action is very fast, less than a second. And then that's the default path on the SCADA system for that operation, for that IIS actually where it's configured. So here's the diagram again. We start project copy, backup, file name. SCADA fetches the file, we send the file with our content which we control. It does something with it and then deletes it. So the second vulnerability that we found was directory traversal for this. So we had nice vulnerability, which is like file upload, but this is not enough for the remote code execution in this case. We control the file name, we control the file content, but it doesn't really mean that we can execute arbitrary code. So for the IIS is if you write the ISP or SPX code, and that can give you the RC if you're able to access this file. So you're thinking like, okay, can we do it? Is it possible for us? And then we thought about the directory traversal. So if we specify, if we do the directory traversal attack on the file name, what will that be accepted by the target? So as a response, we decided to do /se HMI project shell ASP. And then what happens? Target was writing that file actually to that location, to the SE HMI project shell ASP. And that directory was configured as a virtual directory. So if we would be able to access that ASP file, then we could get the code execution. So here is the diagram. So we initiate the project copy. Here we specify the directory traversal this time as a file name. It will still fetch our file and then save it to the SE HMI project shell ASP, and then delete it afterwards once it doesn't need it anymore. So we need third vulnerability, a race condition, right? So we know that this file name will be sitting on the file system for less than a second and then be immediately deleted. So if you want to execute that ASP code, we need to access it as soon as it is written to the file system before it is deleted. But remember, I mentioned before that for the entire chain to work, we needed to have info leaks, because on the very first request, we had to specify the project name. So if you want to do it remotely without any information, obviously that wouldn't work. So we need to have a way to get the full list of configured projects on the SCADA system, and we are lucky to find the API request that was leaking this information to us. And then we are able to craft a valid exploit. So that's the entire process. So once the file has been placed on the file system, we can try to perform race condition to access that shell.asp file and then get the code execution. So in short, the exploitation part is, that's the plan. So we need to obtain the list of projects in the server. So that's our info leak. Then we need to fetch the actual directory of the project so that we can calculate the correct directory traversal path, okay? Because that will vary based on the projects which are configured on the system. Then we need to start our rogue HTTP server, and we need to make it to answer for the factory talk request on the initial ones. Then we need to start a thread that will try to access the path, so the race condition part. So after the malicious file is placed, so that's the part which is trying to win the race. And then when the infrastructure is set up, we just need to issue the request described in the previous section, and then initiate a remote project copy, and we win, and that's sufficient. So that's very simple bug, purely logical bugs. So no like exploitation in terms of memory corruption, not very difficult to find. So yeah, that's just, you can see these bugs are also lurking in embedded world or like SCADA world. The second vulnerability and exploit that we used was a bit more complex. So this time it was memory corruption, and the target was TP-Link consumer router Archer running MIPS CPU architecture, and that was I believe that was our first edition PWN2OWN when we were playing. So one of the very first exploits that we developed for PWN2OWN. So there is a binary running on this target. It is called con indicator. And the purpose of this binary is to control the LED light on the box. So when the router is connected to the internet, it will shine green. And when the router is not connected to the internet, it will be, I think, red or something like that. So that basically gives a feedback to the user, is the internet available? So how does it know if the internet is available? Is that implemented the function to continuously send DNS requests to some predefined set of domains, so like google.com, Netflix, Amazon, and so on. And it will just like continuously send. So if the domain has been resolved, that means the internet is available, and then it can turn the LED light green. And it binds to ephemeral UDP port, which means on each reboot, it will randomly select one of the ports from the 32,000 pool and up. So it is, we mentioned DNS packets. So here's a diagram, and we have to understand the structure of the DNS packet in order to understand the vulnerability and the exploit itself. So here's the DNS request. So that's the packet that will be going to the DNS server. And in the green box, we have the DNS section of the packet. And it starts with the transaction ID, which is a unique value set by the requester that identifies this request. Then we have some flags here. Then information about the number of questions in this packet and some like other info. So in this case, it is 1. And then some other information about other sections. And the last thing is the actual domain that we want to have resolved for, right? So it is encoded in a special way. So the specification says that it is the length value type of encoding. So that means the first byte indicates the size of the value that follows. So here we have 7. So that means we have 7 bytes followed, which is ASCII encoded TP-Link. So after 7 bytes, we have now 3, which means there will be 3 bytes of value. So in this case, com. And then it continues, and then it finds a null byte, which means that was the end of the query name. That's how it indicates. So we know that this DNS request is a query to resolve tplink.com domain into the IP address. So notice that the dot is not part of this encoding. It will be added automatically, so you don't have to put it into the request. So after the request has been sent, the DNS response arrives. And let's see how the response looks like. So this is the response packet. And here it starts with the transaction ID, which is the same number as it was sent in the DNS response. So this is the way to identify that the requester can identify if the received response is the matching one. So is it for my request? So yes, that's the same transaction ID. So that's the matching request. Then we have some flags, number of questions in a packet, number of like answers, some other like information about the structure of the packet. And here you can notice that this is the exact copy of the request that we have. So you can see the 0774, it is exactly as this one. So the response contains the actual domain name that was asked for. So you can even here, you can see tplink.com in ASCII. So we know what domain was asked for, so we need to have a way now to find the IP address somewhere, to what IP address it resolves. So here's the section for this. So here's the answer section. And now it is important to understand that DNS specification implements something which is called compression mode. So since the domain name was already included in the packet, you don't have to specify it again. You can indicate this by putting two most significant bits here, saying use a compression mode, and that what is followed is the actual offset to the domain name that I will be providing IP address for. So here it is C, so that means two most significant bits are set. So there's the compression mode, name is a pointer, so that's the pointer 28 pointing here from the beginning of the header, right? So we don't have to repeat it again, so you can just skip it. And then what follows is just the properties of this answer. So what kind of answer it is, how long it is valid, what's the address length, and eventually the IP address. Okay. So we go further and let's see what was the actual vulnerability and how CON indicator is dealing with that DNS packets. So in the DNS reply, you can send up to 2,960 bytes. And then TP-DNS receive and resolve function is receiving this data from the socket and placing that on the DNS answer buffer. After that, it is calling process resolved IP address, which as a first argument, it is taking pointer to this buffer, which holds our raw DNS data that was received. It set up its own stack with some stack variables. It sets two important buffers: resolved IP, 256 bytes, and DNS query buffer, 260 bytes. Then some answers, and then return address stored on the stack, and some typical stuff for stack frame. After that, it is calling DNS answer parser, which is operating on two buffers. So notice it is receiving as well the pointer to DNS answer with our raw data, and then the pointer to the DNS query buffer, so to this one. And it's a completely different function, so it is not operating on local buffer, but it's operating on the buffer of process resolved IP. All right, so what happens what is happening in a DNS answer parser? So in this function. So here is the compiled view of that function. I've put some like comments and symbols and after reversing. So you can see here when it starts, kind of, it is checking for this compression mode for the pointer. So it's doing the logical AND operation to check if two most significant bits are set or not. So if it detects they are set, so it knows it's a pointer. So what it will do is just like call itself again with the offset to that section in the packet. But if it's not, then it knows that it expects length value format, so length string. So it's like here. That's the part it expects, and it goes to this part of the code. And then you can notice that this is actually do while, so it will continue. It will run in a loop. So we know this actually going into this section first. And what it is doing, it is just like getting the first value of the packet, so which is the length, and it is performing mem copy of our raw data into the DNS query buff. Okay, and on each iteration, it is adding the dot file here after it enters. So like it is parsing this length value until it reaches the end. However, what happens here is that it is processing data in a loop, but it doesn't check in any place if the DNS query buffer is large enough to store all the data that it is processing. So we can actually send a sequence of length string value to overflow DNS query buffer, right? And then we need to terminate with 0. And as we can send up to 2,960 bytes, we can do buffer overflow, smash all the variables, and then eventually control the return address. So that's the situation over here. So it is a perfect situation for us because we can control the return address, which should lead us to code execution, if you're lucky. But there are some problems, right? So, well, first of all, we know that the system is imported into the binary. So the exploitation strategy could be that we will just call system with the command that we control, and that should be a quick win. Well, not so fast. So there are problems. When we crashed the binary and then we checked which registers we control, we noticed that the buffer with our data that we control, that we could potentially put the command string, is not in the register that we need. So that's not very useful. And then we saw that the binary itself is quite small and has very few gadgets, especially for MIPS. So we couldn't just run, Ropper or Rob gadget, find some like list of gadgets and then build a Rob chain. So it was not possible with the constraints that we had. There was simply too little gadgets available. ASLR was on everything except for stack, heap, and leaps. Actually, no, sorry. So on everything else, like stack, heap, and leaps was ASLR, and then not on the binary. So we had a command. We could also. So our command was restricted up to hex 3f size. So also not much. So we have to be careful, craft the command if you want to. So what can we do with this? So we noticed that the process resolved IP can call memcopy twice if we carefully craft our input. So we can kind of control the execution path, and then we can call memcopy twice. So what this gives us, that we can try to abuse it and place our command content, so like a command string, into the read-write data buffer. So like a global section of the binary. Then we need to create our custom ROP chain to invoke system and command that we send, and that's it. So our custom ROP chain is actually a few gadgets. So the first one is to copy the. We need to set up our registers. So remember when I said when we crashed the data, the registers were not really as we expected. So we had to first gadget needs to fix the situation. So I have to prepare our registers that we will be using for the second gadgets for the mem copy. Then the second gadget will jump to the middle of the function that mentioned and execute the mem copy of our command to a non-fixed RW data address. And after that, we can just jump to the system with command as a parameter 0, pointing to our data, and that should be it. So the situation is like this. Copy our command data to memory address that is readable and writable. So that's our W data address, and you can see that's the address that we can use entire thing. Second thing, we need to set up the A0 register to point to the data section of address. So here, where we just overwritten our command. And then the third step, just call system with our A0 register and achieve command execution. So we know system was also imported, as I mentioned before, and it will be at the fixed address of this one. So the attack plan is there. I'll just like maybe show the very few steps how that can be achieved. So we know the binary data section. So we know the range of the memory address that we can use. And here is the IP log of the process resolved IP. So that's the moment where it kind of like crashes. So you can see it is restoring a lot of stuff from stack to the registers, and then calling the jump on the array. So here we need to put the address of our first gadget. And we found manually on this gadget that is setting up stuff for the mem copy. So let's see on the next stage. So here, as the first execution, it loads address of the second gadget to the array. So this is the gadget the second gadget that will actually get the mem copy. So that's the setting up the next address where it will be jumping. So chaining gadgets together. So the next execution here, it is storing the data section address, so one of the address from here, into the V0, which will be used later. About those, we don't care. They're not useful for our or important for our ROP chain, so that can be anything. And here on this one, actually, we need to put a proper size value of the S0 because that will be the size value of the mem copy that will be used. So, and after this few instructions, we have set up some of the register that we need for the mem copy operation, and then we can jump to the actual mem copy operation when it's executing. So gadget 2, mem copy. So it is first sets A0 of address of data section. So that's this execution from the V0. So that's actually, remember, that was here. So we store data section address to V0, and now it is putting that into A0. Then jumps to the mem copy, and then delay slot sets the size that we also set on a previous gadget. And then A1 is already pointing to a stack that we control, and is basically performing mem copy of our control data with controlled size to the memory address that we specified. And then because we are reusing the second memcopy function in the memcopy in the function, we return to the same to this epilogue again on the very initial one to this one, and then we can set up the rest of the game plan. So we can set up the A0 to point to data section address that we just overwritten our command, and then eventually call system with the fixed memory address with our parameter. And this is then executing code on the target and getting a root shell. So I know it's quite difficult to explain this in such a short time, and we actually created a very detailed video on how we found this vulnerability and how we exploit it on our YouTube channel. It is over 1 hour long length of video, so you can go there and watch everything in details, much more details than I was able to provide here. And with this, I'd like to thank you for attention and for the chance of the presentation. You can visit our YouTube channel for more content like this. As said, we'd like to upload a lot of videos on hardware, on methodology, hacking, exploitation. On our website, flashback.sh, we post advisories and technical blog posts. You can find us on Twitter with the FlashBack.PWN. And as I mentioned before, we also run the professional trainings right now. So we will be having the 4 days trainings in end of November, hunting 0 days in embedded devices. And as a thank you for the committee, for the SysPWN committee, we decided to give a discount for anybody who'd like to sign up. And that's it from my side. So if anybody has any questions or comments, I'll be happy to take it.
Okay, thank you very much. It was perfect presentation, and thanks for this special discount, Radek. It was perfect. I personally really like the content. Although this is not specifically my specialty in embedded systems or something like this, but it was really a nice presentation. I appreciate you. So I'm going to enable the chat, and I think everyone can unmute themselves. So if there's some questions, let's go on and ask the questions directly from Radek. And after that, there are some small questions that I will go through with Radek. Yeah, thank you. Okay, so if someone has, yes.
Sorry, I was struggling.
Yeah.
I was struggling with the mic. Okay.
Yeah.
So yes, thank you very much. Really nice presentation. I watched already the video you mentioned on your YouTube channel. Pretty cool as well. Thank you. So the question is more about the PWN2OWN conference. If you could, you already did somehow, but if you could explain how much time usually the teams have and how is the environment during the competition? Thank you.
So you mean how much time for exploitation, right? I believe.
Yes, exactly.
Yeah. So in the competition, you have 3 attempts, and each attempt is 5 minutes. So if you so basically you have 5 minutes time. But if you, for instance, crash the service without exploitation, your attempt is over. So you can even before the 5 times. So you have only 1 attempt per 3 attempts, so to say, right? But if you, for instance, your exploit might take 4 minutes because of, I don't know, some race condition or some like special conditions that you need to meet, it's all fine. But you cannot have more attempts within 1 5-minute block.
Got it. Thank you.
Yes, we have a question in the chat section that how much do you spend within Recon for your targets, and when do you decide the target is not worth the level of deeper dive efforts? Yeah.
Yes, it's very difficult to answer for this kind of questions because it really depends on the experience and the gut feeling of the researcher. So I usually try not to rush with the recon. So usually what we do, we just like try to play with the target, see what it's doing, do some like, stress tests to see observe the log files, what is doing the console log and this kind of stuff, because that gives some information and inspiration. But obviously for Pwn2OWN, you have a lot of targets, so you also need to move fast. So if you have like, I don't know, 10 targets that you want to assess and you have only 3 months of time, if you see that something is like super complex, maybe it makes sense to move some other target, or if you're stuck on something for a very long time. So I believe with this kind of stuff, you can only the more experience you have, the easier it is to assess when it makes sense to move to the other target. But again, I would just say like spend some time on the recon before you, for instance, always try to find where data is being processed, right? Don't try to reverse engineer data that you don't know even if it can be triggered or not, and what are the conditions. So try to spend time on things that are reachable.
Yeah, perfect notes. So any other questions? I'm going to ask some questions. So the first note is that we're going to publish the recording to YouTube, and probably many people are interested to see it through YouTube. And the thing is, Radek, so what do you think about the recent advancement in AI and the things like ChatGPT or something like this for doing this kind of stuff? So do you personally use them? What do you think about them and the future of cybersecurity and vulnerability research and this kind of areas? Yeah.
Interesting question. So actually, I think that it is still at a very early stage. It will definitely make a lot of progress, but I actually try to use the AI for one of the latest Pwn2OWN competitions, not to find vulnerabilities, but to speed up things like prototyping. So for instance, we had a situation that we had to send packets to the target, and then I asked ChatGPT to quickly write me a script that will do it for me, or spawn some service, and it was unable to do it. I was a bit disappointed by this, but maybe that's why I'm saying it's probably a bit early stage. But my experience with this kind of AI systems right now is that you need to be able to assess the answers that it gives you, right? So if you're able to say if the provided output makes sense or not, because if you explore into area that you are not expert in, it's very easy to get false results and false clues, and then you'll be very fast brought into wrong directions. But in the future, I think it'll be very, very useful.
Yeah, exactly. That's true. So, by the way, you were using the 4 version or 3.5?
The previous, I can't even remember which version was it, but
okay.
that was like 1 year ago, I think.
So probably it was the 3.5. Yeah. So the other question is, based on your personal experiences with FlashBack Team or kind of digging into different target, what was the most hard target that you tried to pwn it?
Good question. So I think so far, the hardest target maybe was Tesla because of the complexity it takes. It's more how to set up everything. And I have a lot of experience in automotive myself, and that took me some time to make everything running and understanding and reversing and getting access. But then also like testing, that's definitely a lot of like a barrier for entrance. Obviously, the mobile phone devices are difficult. That's why we don't see them that much anymore in Pong competitions, because this kind of vulnerabilities are not being published anymore in those channels. And I think also the smart speakers are pretty secure.
Yeah. So based on what you said, that probably we should expect some entries for Tesla or something like this in the next Pwn2Own event. Probably, yeah.
Probably,
yeah.
yes.
Yeah.
That's definitely, it definitely takes some time. It takes a lot of time for research to understand the architecture. It's just a huge system. That's the main issue, because it's not possible to do it in short time.
Yeah, that's true. That's completely true. And we have one other question in the chat section. How do you select your targets for Pwn2Own?
So the targets are selected by the ZDI, so the company that runs Pwn2Own, and they select based on what is how the world looks like. So for instance, when there was a pandemic and there were a lot of like people working remotely, they added a lot of like remote stuff, so like Zoom, a lot of like printers and this kind of stuff that people have at homes or in enterprises, and they're the only ones selecting targets. And they sometimes do cooperation with vendors, so the vendors are sponsoring or they want to sponsor their products, but usually they don't ask for the permission, as far as I know. They just like think, okay, that's a great target. They have the budget for the bugs. Then after the competition, they disclose the bugs to vendors, but they don't usually ask if the vendor is fine to put their name on the competition. So they try to keep it real world.
Oh, that's interesting. So the next question is, everyone knows that you also mentioned that there are some training opportunities that you give with FlashBack. And the thing is, my question is, for someone who is into these kind of areas of research, do you somehow recommend someone to attend your training to be ready for Pwn2Own? Or do you think that it will be enough? And are you going to somehow provide your approaches for pwning specific devices and making participants ready for Pwn2Own competition? What do you recommend?
So I'm of the student when they enter the training, but our training is aimed to give a complete path for the researcher. So we focus on methodology and finding the vulnerabilities. And that means how to do the recon, how to get the device, how to get the root shell for debugging, how to dump the firmware, how to emulate it, reverse engineer, and find the vulnerabilities and exploit it. So we focus on different type of classes of vulnerabilities, how to find them. So essentially, throughout the course, the person has a very good understanding where how to find them, what kind of things to be careful with, and where to put attention on, and where to focus when analyzing embedded devices.
That's interesting. So I guess that training would be a mixture of finding vulnerabilities and trying to exploit them.
Absolutely. Yes.
Yeah, that's interesting.
Yes.
Yeah,
absolutely.
Perfect. So yes, I think I also don't have more questions. if anyone wants to ask more questions, feel free to ask, unless we are very appreciating Radek for giving this great presentation and be such generous to give a special discount for SysPWN participant. We really appreciate that.
My pleasure.
And yeah, so I'm also going to record that, and probably Radek will also share the slides with the world. So I appreciate you, Radek. It was perfect.
Thank you very much. I really enjoyed it. Thank you for the invitation and for people joining the meeting.
Thank you very much, and thanks a lot for all participants. Yeah, thank you. Bye.
Thank you.